whenever I started with the first problem that I worked, I labeled my equations 1 and 2. I told you what I was going to do. I was going to take negative 2 times equation 1 and add it to equation 2 when we're going to be dealing with systems of equations. The same thing's going to happen with matrices, only instead of essentially equations, they're going to be rows. And this is the notation your book is going to use. And then when you start messing with this stuff with the calculator, you're going to basically tell me this is what you do if the calculator's doing the work for you, so I know how you work the problem. When you're looking at capital R3, what this is going to mean is new row 3. You're going to create a new row 3 by taking negative 2, multiplying it times the old row 2, and adding it to the old row 3. Now, I did create something when I worked this problem. I took negative 2 times row 1, added to row 2, negative 2 times row 1, added it to row 2. I got something new, which I used to solve the equation. So this would be a new row. So this tells me what they want me to do. They want me to create a new matrix. And the new matrix is going to be gotten by creating a new row 2 in the matrix. So it's going to replace the existing row 2 by taking negative 2 times the old row 1 and adding it to the old row 3. Row 2. So new matrix. Now that means that I'm replacing only row 2, which means that row 1 doesn't get replaced. So row 1 stays, and it says, what does it want me to do? It wants me to take negative 2 times row 1, add it to the existing row 2, and to give me a brand new row 2. Negative 2 times row 1 is going to give me a negative 2, a positive 6, and a negative 2 times negative 3 is positive 6. Add it to the old row 2, which is 2, negative 5, negative 4. My new row 2 is going to be 0, 1, 2. Now what I have created was a new matrix. We call this new matrix not an equal, but an equivalent matrix. In mathematics, what equivalent means is this. It has the same solution set as the original matrix. So if I were to solve this matrix and I were to solve this matrix for an array represent variables like x and y, the solution of it for x and y for this matrix would be the same as the solution for this matrix. They're not equal, but they are equivalent. That's why when we start working with this stuff, what you will never find me do is to put equals between the matrix. Matrices are equal only if they're identical. So in other words, if I wanted to have the idea of equality, I could say matrix 1, 2, 3, 4 is equal to another matrix only if the inside of the second matrix is 1, 2, 3, 4. They have to be literally identical matrices. That's saying, like saying, the number 2 equals the number 2. They have to be identical. That's how two matrices are equal. So that's why we say they are equivalent, not equal. They can't be equal. Because these two guys certainly don't look the same. So we come over to this one, and it says create a new matrix. Now how am I going to create a new matrix? I'm going to replace row 2. That's a new row 2 I'm going to create by taking negative 2 times the old row 1, adding it to the old row 2. I'm going to create a new row 3 by taking 3 times row 1, adding it to row 3. And none of this, you notice, row 1 is not replaced, which means row 1 is going to stay. So it's negative 1, negative 3, 3, and negative 5. So 1, negative 3, 3, negative 5. But the other two rows are going to be replaced. Now, what are they going to be replaced with? Well, it says, give me a new row 2. And the new row 2 is going to be taken by taking negative 2, multiplying it times row 1. You're going to add it to the existing row 2. That's going to give me a new row 2. So that's my replacement row. So negative 2 times positive 1 is negative 2. Negative 2 times negative 3 is positive 6. Negative 2 times positive 3 is negative 6. And here's my constant. Negative 2 times negative 5 is positive 10. You're going to add it to the existing row 2, which is 2, negative 5, negative 3, negative 5. My replacement for row 2 is 0, 1, negative 9, and 5. So that's my new row 2. So it's 0, 1, negative 9, and 5. And then it says, all right, what else does it want me to do? Well, it wants me to replace row 3. It wants me to replace row 3 by taking negative 3 times row 1 and adding it to the existing row 3. So it's going to be 3 times row 1 added to the old row 3. That's going to create for me a new row 3. So I need to take a look at what's row 3, well, what's row 1? Row 1 is 1, negative 3, 3, negative 5. So 3 times 1 is 3. 3 times negative 3 is negative 9. 3 times 3 is positive 9, and then there's my bar. 3 times negative 5 is negative 15. And row 3 is negative 3, negative 2, 4, and 6. My replacement row is 0, negative 11, 13, and negative 9. So it's 0, negative 11, 13, and negative 9. Now you might say to yourself, self, what happened? Here's X. Notice the only row that's got an X in it now is row 1. The new rows I have only have X's and Y's. The only row that has an X in it is the first row. Everybody else is only X's and Y's. Yes?
Wouldn't the 5 on the first row be positive?
No, it's negative.
But did you change it?
let's see, I multiplied by -2. So -2 is -2.
You don't change
Negative,
the first row though.
pardon me?
We don't change the first row though, right?
You don't change the first
Oh,
row.
okay.
Oh, okay. Thank you. Sometimes I need a question interpreter. Because I'm making an assumption as to what question he's asking, and I was wrong.